Want to score easy marks in ICSE Physics? Then don't skip the numericals from work, power and energy. These are among the easiest and most scoring numericals in the entire syllabus. Hello everyone and welcome back. In today's video, we will solve some important numericals from the Concise Physics book itself. If you understand the concepts and practice these questions properly, you can confidently score full marks in this part of your exam. So keep your textbook, notebook and pen ready and let's begin. Let's see the first question. A body when acted upon by a force of 20 kgf. So we will write force equals to 20 kgf. Gets displaced by 1 meter. So displacement is 1 meter. S equals to 1 meter. Calculate the work done by the force when the displacement is in the direction of the force. So work done is what? Force into displacement and it is in the direction of the force. So W equals to F into S and F is 20 but we will convert it into Newton and multiply it by 10. So when you convert kilogram force to Newton, what you do? You multiply it by whatever the value of G they have given. Here they have given it as 10, so we will take 10. 20 into 10 and into displacement is 1 meter 1. Everything should be in SI unit. So we are getting how much? We are getting 200 joules. We are calculating work, so it will be joules, right? Second question, number B. At an angle of 60 degree with the force. So whenever the displacement is at an angle, the formula that we use is W equals to Fs cos theta and F will be same, which is 20 into 10 Newton we are converting it to, and S is given 1, we will take 1 and we will take cos. What is the angle they have given? That gets calculate the force and at an angle of 60 degree. So cos 60 degree. Now we have to put the value of cos 60. What is the value of cos 60? 1 upon 2. So we will write 20 into 10 into 1 into 1 upon 2. This one we can even skip writing to 10 times. So we will get 10 into 10 which is 100 joules. Next, third, normal to the force. We have to calculate the work done when the displacement is normal to the force. So normal, which means perpendicular 90 degree. So formula will be W is equal to Fs cos theta and we will take cos 90 degree because it is normal to the force. Normal is perpendicular, which means F into S into cos 90 and cos 90's value is 0. So we will get the work done as 0. So the answer will be 0. So we are done with A, B and C. We have simply used the formula W is equal to F into S and Fs cos theta if the displacement is at an angle with the force. Right? Let's see the next question. Question number 2. It says a boy of mass 40 kg climbs up the stairs. So mass is given 40 kg. Climbs up the stairs and reaches the roof at a height of 8 meter. So the displacement S is 8 meter and the time taken is 5 seconds. So we will write time equals to 5 seconds. Now calculate the work, calculate the force of gravity acting on the body. So force of gravity is how much? Force of gravity is M into G. So force of gravity is M into G and M is 40 into gravity. G they have told to use 10. So we will take 40 into 10 and we will get 400 Newton. So force of gravity will be 400 Newton. Second is the work done. So work done, how do we calculate? Work done is force into displacement and force we have got 400. Displacement is how much? 8 meter they had given. So 400 into 8 and how much we will get? 3200 joules. Then power spent by the boy. Power, what is the formula? Work done upon time taken. Simply we will use that. P equals to W upon T, and work done is given 3200. So 3200 upon time, and time is 5 seconds. And just get the answer. 640 watt. And this is how we can solve this question. A man spends 7.4 kilojoules of energy in displacing a body. So this much is the energy. So energy is how much? 7.4 kilojoules. Now we should always convert our values in SI unit. So we will write 7.4 into 1000 joules. Now in displacing a body by 74 meter, so displacement S is 74 meter in the direction in which he applies the force in 2.5 seconds. Time is also given 2.5 seconds. We have to calculate the force applied. Force we have to calculate. Force is question mark. How do we do? So simple. Energy means work done. So this is work done, this is displacement, this is time. And they have asked us to calculate force. So we will use the formula. Work done is equal to force into displacement. And work done is already given to us. 7.4 into 1000. We will write that. 7.4 into 1000. Force we don't know. So force we will write F. And displacement is given 74 meter. So into 74. Now we have to get F. Very simple. So just calculate 7.4 into 1000 upon 74. Just calculate and get answer. So after calculating, you will get it as 100 Newton. Next subpart, the power spent in horsepower. We have to calculate the power in horsepower by the man. So first let's calculate in watt the power, and then we will convert it to horsepower. So power is equal to work done upon time taken, and work done is already given 7.4 into 1000. We will write 7.4 into 1000, and time is how much? 2.5 seconds. So let us just calculate it. So after calculating, we are getting 2960 watt, but they have asked us in horsepower. How do we calculate in horsepower? So we have to know that 1 horsepower equals to 746 watt. So if we have to convert this to horsepower, what we will do? We will write 2960 upon 746, and we need to solve it. If we solve this, we will get this as 3.96 horsepower. So the question was in horsepower, so it will be 3.96 horsepower. That will be our answer. So in this question also, we simply use the formulas. Work done is equal to force into displacement. We got our force, and we should know how to convert watt to horsepower. So 1 horsepower is 746 watt, and from there we can get that. Let's see the next question. Question number 4 is, a weightlifter lifts a load of 200 kgf to a height of 2.5 meter in 5 seconds. So he lifts a load of 200 kgf, which means that force is equal to 200 kgf. They have told use G as 10 Newton per kg. So we will write 200 into 10, which is 2000 Newton. And time is given to us. This displacement is given. So okay, first let me write time is equal to 5 seconds. And displacement S is given 2.5 meter, And we have to calculate the work done. Simple. Work done is equal to force into displacement. Force is 2000 and displacement S is 2.5 meter. 2 into 2.5. Simply calculate. So it will come 5000 joules. And then power developed. So power is equal to work done upon time taken. Work done we already got 5000 and time taken is 5 seconds. So 5000 upon 5. We will get 1000 watt. Always write the unit in the final answer. So power is 1000 watt. And this question was also very easy. Just using the formula W is equal to F into S. Work done is equal to force into displacement. And power is equal to work done upon time taken. We can calculate this. We can solve this question. Let's see the next question. Look at this question. A machine raises a load of 750 Newton. So force is equal to 750 Newton through a height of 16 meter, which is displacement is 16 meter. Time is 5 seconds. Calculate the energy spent. So energy means work done. So we have to calculate work done. And how we will calculate? Force into displacement. Force is given to us 750 and displacement is given to us as 16 meter. Simply multiply and get answer. We will get 12,000 joules. Work done we got. And now we have to calculate the power. Simple. Power is equal to work done upon time taken, which is 12,000 upon 5. And we will get 2400 watt. And this is how very simply we can calculate. Let's see the next question. See, an electric heater of power 3 kilowatt. So we will write power is equal to 3 kilowatt and convert it into watt. 3 into 1000 watt. For 10 hours. It is used for 10 hours. So time is equal to 10 hours. But this is not the SI unit, so we will convert it to seconds. 10 into 3600 seconds. Now, how much energy does it consume? Express your answer in kilowatt hour. So, kilowatt hour they are telling, we have to tell our answer in kilowatt hour. So, in kilowatt hour, we simply do energy. So, energy is equal to power into time. Now, since they have told us to calculate in kilowatt hour, we will simply do 3 kilowatt into 10 hour and we will get 30 kilowatt hour. Then we don't need to convert it into watt and seconds. Now they are telling convert it into joules. So in joules, we have to remember that 1 kilowatt hour equals to 3.6 into 10 to the power 6 joules. And we will simply multiply to get our answer. So 30 kilowatt hour into 3.6 into 10 to the power 6. And we will simply multiply and we will get the answer. So we will get 108 into 10 to the power 6 joules as the answer in joules, the energy consumed in joules. Simply we multiply by 3.6 into 10 power 6 and we get 108 into 10 to the power 6 joules, right? Let's see the next question. Okay, let's solve question number 7. A water pump raises 50 liters of water through a height of 25 meter. So volume of water is 50 liters. Displacement S is 25 meter. Time is 5 seconds. We have to calculate the power. Power is equal to work done upon time taken, right? And what is the work done? So work done equals to force into displacement. Force is M into G and into displacement, which is 25 meter. And what is the M? How to get the mass of water? So we know density of water is given to us as 1000 kg per meter cube. We know that density is equal to mass upon volume, right? We have to calculate mass. So mass is equal to density into volume, and density of water is given 1000 kg per meter cube given, and volume is given in liters, but we have to convert it to meter cube. How to convert? So 50 upon 1000, and we get 50 kg. So mass of the water is 50 kg. We will write 50 into G. The value of G is 10. So we will take 10 into 25. And work done is coming as 12500 joules. But we have to calculate power. So power is equal to work done upon time taken. We will actually write 50 into 10 into 25 and upon the time, which is 5 seconds. So what we will get? 10 times, which means 2500 watt. We are calculating power, so 2500 watt. So this is how we can calculate the power of the pump. They had asked us to calculate simply, and my pump was 100% efficient. So the power will be what we got, that is 2500 watt. Let's see the next question. Another question on pump. Let's see this. It says pump is used to lift 600 kg of water. So mass of water is 600 kg from a depth of 75 meter, which means displacement is 75 meter. Time they have given is 10 seconds. We have to calculate the work done. So work done is equal to force into displacement. Force is M into G into H. So M is 600, G is 10, and height they have given 75 meter. So this will be our work done. Just multiply and calculate. So work done will be 4,54,500,000 joules. We got the work done. Now the power at which the pump works, we have to calculate the power. So we know that power is equal to work done upon time taken. It is 450,000 upon time, and time is 10 seconds. So we will get power as 45000, that is 45,000 watt. So power we got. And now power rating of the pump, if its efficiency is 40%, which means that the pump is not 100% efficient. It is only 40% efficient. So this is 40%. We have to calculate 100% is how much. That is the power rating of the pump. How do? We can use ratio method. That 40% is equal to 45,000. So 100% equals to how much? So that is X, and just calculate. 40 into X is equal to 45,000 into 100. So X equals to simply calculate this, and we will get the answer. So after calculating, we will get 112500 watt, and we can also convert this to kilowatt by dividing it by 1000. We will get 112.5 kilowatt, and that's how this can be calculated. Let's see the next question. Now this question is, look at this question. An aux can apply a maximum power of 1000 watts. So power is given to us. An aux can apply a maximum force of 1000 Newton. So force given to us is 1000 Newton. It is taking part in a kart race and is able to pull the cart at a constant speed. So speed is given to us as 30 meter per second. So the cart pulls at a constant speed of 30 meter per second and we have to calculate the power. So we know power when you have to remember the formula P is equal to F into V. So we will use the formula P is equal to F into V. F is given, V is given. We simply multiply and we can calculate the power. So this is an important formula which you have to remember for calculating such questions where force is given and velocity is given. So we will calculate power as 1000 into 30 and we will get 30,000 watt. So this will be the power of the developed by the ox. We can also convert this to kilowatt by dividing it by 1000. So it will become 30 kilowatt. Even if we leave the answer here, you will get full marks. And you can also convert it to kilowatt because that value is a big value. It can be converted to kilowatt. So you can convert it. Right? Let's see the next question. Now the question number 10 is the power of a motor is 40 kilowatt. So power given to us P is equal to 40 kilowatt. At what speed can the motor raise a load of 20,000 Newton? So this is force, right? So force is given to us as 20,000 Newton. What we have to calculate at what speed? So again we will use the formula P is equal to F into V, which means you have to remember this formula. You can't afford to forget it. P is equal to F into V and we can simply write 40 equals to 20,000 into V and let's get V. So V will be 40 upon, by the way this power is kilowatt, let's convert it to watt. 40 into 1000. So here also 40 into 1000 upon 20,000. So we get 2 meters per second. And the question is very easy, but if someone does not remember P is equal to F into V, you won't be able to solve the question. So please remember the formulas nicely. Let's see the next question. Let's look at this question. Rajan exerts a force of 150 Newton, which means F equals to 150 Newton in pulling a cart at a constant speed of 10 meter per second. So velocity is equal to 10 meters per second and calculate the power. So power we have to calculate. We will simply use the formula P is equal to F into V and we will get the answer. Let's get it. P is equal to F into V, which is 150 into 10, which is 1500 watt. Or we can write 1.5 kilowatt. And we are done. Simple question. Let's see another question. Let's look at question number 12. A boy weighing 350 Newton. So force is equal to 350 Newton. Climbs up 30 steps and each step is 20 centimeter high in 1 minute. Calculate the work done. So work done is equal to force into displacement. Now force is 350 Newton. How to get displacement? Total 30 steps, which means 30 into 20 centimeter high each is, we will convert it to meter, 20 upon 100. And displacement, so this is force and displacement. So let's calculate 350 into 6. We will get 2100 joules. And now we have to calculate the power. So we know power is equal to work done upon time taken, which is 2100 upon time taken is 1 minute, and we will convert minute to seconds because that's the SI unit. So we will write 60 and so power will be 35 watt. And that's how very simply we can calculate this. I hope you found this easy, simple. Let's see the next question. Let's solve the next question, question number 13. So question number 13 says, it takes 20 seconds for a person A of mass 50 kg to climb up a flight of stairs. So there are two persons, one is A, another is B. The work done by both of them is same. We have to compare the work done. So work done by A and B will be equals to 1:1, as because they are doing the same work. Because how we calculate work? Force into displacement. They have the same mass, which means force is m into g, mass is same, which means force is same, and the distance is also same. So work done is same. But they are now power developed by A and B. We have to calculate the power. So power of A will be work done upon time taken, and which is W upon A takes 20 seconds to 20. This is power of A. And power of B will be work done upon time, and time is 15 seconds. So we have to calculate the ratio, compare the power. So power PA upon PB, we have to calculate. PA is how much? W upon 20. So we will write W upon 20 and we will write divided by W upon 15. So we will get W upon 20 into 15 upon W. Simply calculate and get the answer. So we are getting the power of A is to power of B is 3:4. Let's see question number 15. It says, a man raises a box of mass 50 kg to a height of 2 meters in 20 seconds. And another man raises the same box to the same height in 50 seconds. We have to compare the work done by the two men. So work done, see they are doing the same amount of work, will be same. Comparison will be 1:1. But let's calculate the work done. So work done is equal to what? Force into displacement. Force is how much? M into G. M into G into the displacement, which is 2 meters, that means the height, S I should write over here, so I'll make it S. And mass is given as 50. G, the value of G they have told to use 10, we will take it as 10. And the value of S, displacement, is given 2 meters, so we will write 2. And we can get the answer as 1000 joules. So this is the work done by each man, 1000 joules. And work done by the two men is the same. So the ratio is 1:1. Second is the power developed by them we have to calculate. So power, how do we calculate? Power for the first person is, I am naming it as A. PA is equal to 1000 upon. Look at the time. The first man takes 20 seconds and the other takes 50 seconds. So 1000 upon 20, and power of B is 1000 upon 50, right? Let's calculate. 50 watt, and power here is 20 watt. So power developed by each man, one is 50 watt, another is 20 watt, and we also had to compare their powers. So when you compare, what you can do? 50:20, which means you will get 5:2. So this is the power developed by them, 5:2 ratio. And if you have to calculate the value, we will get power of A is 50 watt and the power of B is 20 watt. I hope the question is clear to you. Let's see the last question. A boy takes 3 minutes to lift a 20-liter bucket of water from a 20-meter deep well. while his father does it in 2 minutes. So boy and man, right? Now 20-liter bucket of water from a 20-meter deep well. So work done will be what? M into G into H. Now 20-liter bucket, remember we discussed that 1 liter equals to 1 kg. So 20-liter bucket is, you can calculate also. I showed you how to calculate. So now I am taking 20 into G. G they have told to use 9.8. So we will take 9.8 and into H. 20 meter deep they are lifting it. So into 20. This is the work done by the boy and this is also the work done by the man. Both are doing the same work. So compare the work done. Comparison will be 1:1 because both of them are doing the same work. But if we have to calculate, then we will find out. 2 into 2, 4. So we will get the work done is 3920 joules. So the work done by the boy is 3920 joules and work done by the man is also 3920 joules. So calculate the work done by each will be 3920 joules and comparison of their work done is 1:1. Now coming to the power developed by them. So power of the boy will be work done upon time taken, which is 3920 upon time taken by him is 3 minutes. So 3 into 60, we have converted the time to seconds. And power of the man will be 3920 upon time taken and he takes time 2 minutes. So 2 into 60. Now we have to compare the power. So power of the boy upon power of the man will be equal to 3920 by 3 into 60 divided by 3920 by 2 into 60 and we will get so simply you get 2:3. So power of the boy upon power of the man is 2:3. So we can calculate the power of boy and power of man and we get 2:3 and work done by each of them is 3920 joules or we can also say 3.92 kilojoules. And this is how very simply we can solve this question. So that's it for today's video. I hope these numericals helped you understand the concepts and correct method of solving them. My advice is simple. Don't just watch the solutions. Solve every question yourself. That's the best way to build confidence and score well in your ICSE board exams. If you found this video helpful, please give it a thumbs up and subscribe to the channel. And also share it with your friends who are preparing for the exams. Thank you for watching and I'll see you in the next video. Happy studying!